Hey John, I just finished working on part of the project. I started to mine Bitcoin. I'm not yet able to mine Bitcoin, but I just completed the first part of it, the SHA-256 hashing algorithm that you use when you mine Bitcoin. So I thought I'd make a couple videos about that. The next video I'll really maybe kind of describe that hashing algorithm, but right now I just thought I would give an overview of mining Bitcoin and kind of tell you what I learned about it. So cryptocurrencies and Bitcoin specifically are different than just digital currency in that they have this uh, what's called the blockchain, which is like a linked list of blocks of transactions. And the thing about it that people really like is that um, it's public. Everybody knows it. It's fully transparent. Um, it shows every transaction of every fraction of every Bitcoin. And you can't change it. You can't go back. Nobody can go back, and it's like cryptographically secure. You can't go change it after the fact. And so these blocks are really, they're just like lists of transactions. Kind of, everywhere in the world, people are, transacting Bitcoin, and every one of those gets added to a block. And then when a block is successfully hashed, it's able to be added to this chain, and that's the ledger, that's the blockchain. And the process of hashing so many transactions, where a transaction is of the form, like A gives B X Bitcoin, where each, A and B, they each have like their own unique identifier, and they have keys, and I think they digitally sign it or something. I'm not totally sure about the details of that, of each transaction, what goes into one. But as transactions occur, they kind of queue up in the world, all over the place, and they just kind of wait out there, waiting to be verified. And once miners go and grab a bunch of those and package them up, and then they run it through this algorithm, SHA-256 hashing algorithm. Um, Once they run it through that and they produce a hash that satisfies uh, some particular constraint, then it's been verified and it can be added to the chain. And the miner who does that gets paid. It's up to 6.5 um, Bitcoin, which is about $350,000. So there's a lot of incentive to do this. So basically, what this SHA-256 algorithm does, and um, that's what this first part of the project I worked on. I wrote my own SHA-256 hashing algorithm. Um, the way this works is when you've got a block of transactions that are waiting to be hashed. In addition to the transactions, there's kind of this like header section, and the header section has got, the block has its own ID, and it's got the ID of the previous block, so that it can kind of find its place in the history. And there's like timestamp, and there's all this information in the header, and there's an additional section in the header where the person mining can go ahead and basically put any sequence of ones and zeros in there. Um, it's another detail I've yet to look up, how much space you get, but the miner gets to put in some sequence of ones and zeros, and this is called a nonce, and it kind of adds randomness. And you basically, the process of mining Bitcoin is to basically try all kinds of different combinations of this nonce and run it through this SHA-256. And if your output has a particular property, um, you have successfully hashed the block and you can add it to the chain. Most of the time it doesn't, so you have to use circle back. You sort of check it. You check the block, or you check the hash value. Does it satisfy the property? most of the time it won't. So you go and you change your nonce value, you hash it again, and you just kind of have this loop of hashing and incrementing this nonce and checking and or incrementing the nonce, hashing, checking, and you just kind of do that until you get lucky. And people have they have um, different algorithms to do this. They have specialized hardware, and then there's some luck involved. So the question is, what is the hash? Hashing is kind of like a compression. It's an algorithm where you take some sequence of binary as input and you run it through this algorithm and it kind of compresses it into a smaller amount. The difference is unlike compression where the idea with compression, of course, you go the other way and you can get your original back. A hash is like a one-way kind of function. It's a digest, it's sometimes called. So you take a lot of binary and you can kind of compress it. You can crunch it down in this um, small amount. So SHA-256, it can take anywhere from 8 bits, 1 byte, all the way up to 2 to the 64, which is huge. It's many orders of magnitude greater than terabytes. I think terabytes are on the order of 2 to the 40, so it's many doublings. So you can have anywhere from a byte to terabytes or more input, and you can crunch it down into 256 bits, and that's the hash. And so the idea with this is that you want to take this block, you want to take one of these blocks of transactions, and they're just binary, and the miner can try different combinations for one part of that block, and then you just run it through this hashing algorithm, and your output's 256 bits. And the property you're looking for is that there's so many leading zeros in the output. So I'll just pull up a calculator online for SHA-256. You know, you can give it a few bytes here, and it produces this long string, or you can give it all kinds of values, and it still just gives the same size. So that's an important feature of it too. It always gives the same size. It's one way. You can easily go from the input text to the hashed value, but you can't go the other direction. You can't take a hash value, and there's no feasible way of going the other direction and discovering the input text. And so um, there's no easy way to do that. And so it's like it takes computational work in order to do this thing, and you can't work backwards. So if you got a block of transactions as a bunch of binary, what you want to do is you want this thing to have so many leading zeros, and that's really all you need to get paid. It started out, I think, as just 8 bits. You only needed 8 bits to be zeros. Now it's up to like 20. So over time, that gets harder. It gets harder and harder to find hashes and stuff. So that's the basic idea for hashing. Next time I'll talk about the actual algorithm itself, how it works, and show it working and stuff.